Burkhard,
How you doing?
Good. You've been telling me a lot about this place.
Yeah, we're finally here, and still work in progress, but we're getting there. The entire building envelope is completely consistent, timber framed, and been using our PanelLite system. And the rest of it, you can see the rendered surface on the back of the house. We've got some of it is timber cladding, or the stone cladding here. It's just cosmetics. It's just making it look pretty. It has got zero impact on the performance. So whatever your desired outcome is or look is that you want to achieve, and it has got no relevance to Passivhaus.
That's very clever. Usually all the transition between different building material, building method are the source of all the leakage and all the issues.
Yeah, it's very simple. What we've just done here is just fixing a blue board sheet to the counterbatten, so there's a consistent airflow behind the cladding.
Yeah.
And then the stone is just glued really to the blue board sheets, similar to the render. You know, it's just cosmetics. It's just for really making it look pretty. There's no limit to what you like or what a Passivhaus could or should look like. You know?
And what about this black finish here?
That's just a waterproofing membrane. So what the client will finish this place off by creating sloped garden beds.
Oh, nice.
So you can feel this pretty strong winds here.
Yeah,
you know, it's
there
picking
are.
up. It's pretty much every day in the afternoon the winds pick up.
Yeah.
So they would be building garden beds, sloped back to natural ground level, and so the whole house appears to be tucked into the landscape.
Yeah.
So it'll look pretty smart. So the fire rating is on how to deal with the fire rating. It's no different than you would deal with it in any other conventional house.
Yeah.
So the bushfire rating is based on the classification of the cladding, right? So it'll be metal cladding or stone, or in this one here, he's got some timber cladding.
Yeah.
It just has to be this, I believe it's class 1 durability timber that it just needs to be bushfire resistant to that certain level. All the Passivhaus magic is happening behind the scenes in that Passivhaus certified construction system.
Yeah.
That's all done, dusted, and how you finish it off is then another story.
All right, let's go inside and have a look at the rest of the house.
Let's go.
Wow.
All right, here we are.
Amazing look, massive home.
Yeah, she's a big one. It's about 550 square metre footprint, double story, and an enormous ceiling height, as you will see when you get upstairs. So it's been...
What was the volume?
It's 1,355 square cubic metre.
It's amazing.
So that's, it's quite high. The ceiling height upstairs is amazing. It's got an incredible look.
No wonder they need a lift.
Yeah, that's right. So lift, it was simply integrated. When we started here, we had the concrete slab and nothing else. So we manufactured the steel frame around that lift, because that would have been a nightmare in a completed house to build this afterwards. So everything was pre-manufactured, including the staircase. That's all done out of structural ply. So then we've just lifted in the staircase around that steel tower. And the house was then assembled around it. So it's
Well, when it first started, it looks like a multi-story high-rise apartment.
Right. Yeah, correct.
Amazing. And your wall detail. So you've got your wrap on the inside here, and you've got a bit of a cavity.
Yeah, this is the installation cavity. So as you can see here, this is a perfect example. This is our air tightness layer. This is the Intello, fully sealed around the entire envelope, and all those cables. Any services or pipes as well can be run within that cavity. This stops penetrations through the envelope. Everything, as soon as the power supply is inside the building, we don't need to penetrate the air tightness layer anymore. It's just all sealed from there on in.
Yeah, and your insulation is nice and consistent behind that.
Yes, and, insulation is sealed up in there in our system.
You can make sure that air tightness is where it needs to be, as well as your insulation consistency.
Correct.
All right, let's move on. You're absolutely blown away by this glazing.
This is the living area and kitchen area will be this side, so it's obviously still in the raw stages, but you can sort of get the idea of what this is going to look like. So the kitchen bench wraps around here, and then you can have a decking on the outside and open those windows all the way up.
So that's triple glazing, low E glass?
Low E glazing, triple glazed timber aluminium windows. So everything will obviously have fly screens as well that are bushfire rated. And we've got the same on the other side in the dining area, just in case you don't feel like walking through the 10.5 metre sliding door.
Yeah. Yeah.
Beautiful.
And you've got some steel structure here, which is really interesting because usually we see steel on the outside of the building envelope to hold up all this weight.
Yep, Maxa designed this building, and we've just simply worked with them closely to shift the steel inside the thermal envelope. Using steel is not uncommon, and that's perfectly fine. You see the large spans in here. There is no interruption, that's all open. We just needed to somehow come up with a solution that the steel doesn't penetrate our envelope and gets to the outside. That's the thermal braking we're talking about. So
what would be the consequence if we do it the conventional way?
I've seen this recently, and someone referred to steel as the highway for heat transfer. Yeah. So you're penetrating your building envelope with a piece of steel. Whether it's boiling hot or freezing cold outside, steel is a conductor. So that just conducts anything, whatever's on the outside, straight back into the building envelope, creates a cold surface, and a warm environment creates condensation. As simple as that. The insulation is under the concrete slab. Yep. So the concrete slab has been polished before we actually got here to the first extent. So this is a simple bracket that's mounted onto the concrete slab. The post basically sits like a sleeve on top of it. So you've got because this will be exposed, you've got a hidden fixing there. And the thermal braking is done under the concrete slab. So this is all done behind the scenes. And the slider has got a hard compressed foam block underneath as well, which is the thermal braking. So that gives you this threshold finish here. There is no step in this house. So you can see this was really smart planning to retire and live here for the rest of their lives in this house, having a lift in the house to get up to the bedrooms. No steps in here. This will lead you out onto the deck. It's wheelchair friendly. All the doors have got a magnetic seal on the underside, so there is no threshold on those doors. Everything is perfectly flush. As you close the door, the magnet pops up and seals it perfectly well to Passivhaus.
How big is this glass door?
This is 10.5 meters. This is 1 out of 3. So this is a 10.5 meter sliding door. Each pane of glass was about 250 kilos, which had to be glazed on side. And the frame itself is another 200 kilos, so about 1.2 tons of high performance windows and doors here. Wow. You can see, I always this is that prime example for people that believe that Passivhaus can't be used in Australia because we like the indoor-outdoor theme. We like entertaining, we like opening all windows and doors because our climate is wicked. You can in a Passivhaus, 100%. And you see, this is 1/4 ton of glass.
I mean, Joseph and I talk about this all the time, where if you can't afford the proper glazing or for this sort of outdoor living, you shouldn't be doing it at all. No. I mean, you can get cheap single glazing to do this, but the overhead on your heating and cooling costs and your comfort is astronomical.
And it's the health, the health aspect there. That was in New Zealand had the founder of Woofy, the moisture management program, was over there recently, and he's saying that in Germany we started insulating for health, not for energy efficiency. Energy efficiency is a nice byproduct that just happened to be more energy efficient, but the health factor and the comfort factor was the big one that we're aiming for. So we're all human beings, we're like entertaining, we're being social, we're opening windows and doors, allow the breeze to come in. There's nothing wrong with that. In any Passivhaus you can do this. But if the weather changes and it turns nasty, you close the doors and you're back in charge. Absolutely. It's fantastic.
The R value that you got on your walls?
R4 insulation bat plus the build up, so you're in and around R4.1. That generally gets you over the line. Concrete slab, you've got an R2.5 or R3 in the concrete slab in XPS.
Wow, that's good.
And in the ceiling, we've manufactured curved roof panels.
Yes.
And they've got a R6, I believe it is. So whatever the roof cavity is, we're pretty much guided by the structural engineer. He tells us, okay, it spans X amount of meters, therefore your build-up will be 300 mil. We're fully insulating that cavity, whatever that is. The glass U value is about 0.6. So that's the best performing part of the entire frame. The frame itself has got a U value of about 1.1. So overall, the total U value will be, I think, about 0.9. So extremely high performing windows, triple glazed, timber aluminium, no maintenance for life. It's just a great product. It's 1/4 ton of glazing each panel. So it's rather painful to install, but once it's in, it's in.
Guys, let's go upstairs and have a look what's going on up there.
There you go.
Nice.
Welcome
Very
to
nice.
upstairs. So you can see the ceiling height. It's quite vast in here.
This is amazing.
We've manufactured, we had pre-curved, glue laminated beams and made roof cassettes out of this. And this part was supposed to be a suspended ceiling, so a level ceiling going down from the lowest point across. And we're standing in here, and Tom, our client, does a lot of the work himself. He goes, "There's no chance we're going to cover this up. We're going to."
Okay, Burkhard, so talk to us about prefab construction. What are the benefits of it?
The main benefit, of the obvious benefits, is time. We're being quite remote here in Deans Marsh, and there is just simply no labour, no experience available to build Passivhaus to that stage. You can see the ceiling height here. You'd be up on the scaffold tower, up and down all day long. So we can build a much better performance to Passivhaus, which is the highest energy efficiency standard in the world, and we can build it in a fraction of time. So these are the obvious benefits. Then the cost-related benefits to that, reduced project managing and so on and so forth. The next one is waste reduction. You can, on a site like this, you can see there is generally, I'd say somewhere between 10 and 15% is the average what just goes straight in the bin, and most of it unfortunately is straight to landfill as well. In the prefabrication, we can reduce this. We've recently analysed this down to about 2.75%.
Wow.
So there is just the software before houses are built. Houses are created and built on the screen. So when it actually comes to the prefabrication and the assembly, that's the easy part. That's the predictable part. Houses are constructed on the screen, and the software helps us to analyze and maximize the outcome of every piece of timber. So it can look at the entire building envelope and picks out 2 pieces of timber out of this wall, one out of this and one out of this, lays it out on a 6 meter length of timber, and the machine automatically cuts it.
That sounds like people doing the fashion industry, how they cut a piece of fabric.
That's right, yeah. And the offcut is then all of a sudden 30 mil of timber rather than 1.5 meters that you can never use again.
Oh, that's amazing.
Yeah. So in another challenge is that a curved roof, and being up on the roof, the health and safety is one of the big issues. Climbing up on the roof, and the current scenario is that people climbing from rafter to rafter all day long. That's unfortunately the reality.
I didn't think of that.
So all the roof cassettes are fully sheeted up on the top. So it's basically like a massive dance floor up there where it's just safe to walk.
And you've made it on the ground, and then you've just made it, and then
We've got
put it
it
up.
built on a solid concrete slab off-site in our facility. It's never too hot, it's never too cold, it never rains. We're just maximising how much we get out of every single worker, and our team has been incredible because they're delivering just the highest energy efficiency standards right here in Melbourne. You don't need to go to Europe for this. It's manufactured here in Australia.
Oh, that's great. So even in highly built up area, you practically, if you do prefab, you keep the neighbors happy.
Yeah.
Because it's a lot quicker, not as much noise generated locally on site.
That's right. We can simply create buildings that are safe, that are comfortable, and energy efficiency becomes a usable, nice little byproduct.
And you can also quality control the insulation and the wrapping that you got on each building, on each wall and ceiling as well.
Quality control is one of the, from a builder's perspective, one of the big items. I can guarantee you that this house will perform. I can guarantee you the thermal performance, no thermal bridging, air tightness, all of those is predictable. And in times like today, predictability is something that is rare in the construction industry. We can guarantee timeframes, we can guarantee budgets and deliver on time.
It's a pretty decent sized skylight in this room.
Yeah.
Yeah. What kind of performance is required?
We've got, because of the size, we were limited to, or we had to create actually 2 glass panels rather than one big one. These are double glazed and they're high performance skylights as well. I suppose that is an idea to overcome one of the big disadvantages with Passivhaus. There is no noise. you can't hear the birds, you can't hear the rain, so you can have it in a skylight, the rain is sort of trickling down, they will set up the bed in the center of the room and you can listen to the sound. So the key here was really, it's overheating obviously in Australia compared to Europe, and these have got solar powered blinds on it, and they've also connected to a weather station. So obviously when it starts raining, they close themselves automatically, so they're openable with a little motor, and they've also got solar blinds on there, zip screen blinds to block out the heat and block out the glare. The entire house is obviously controlled by the heat recovery ventilation as well. If you want to open all your windows and doors, fantastic. If you do not, because it does get quite rough out here as well, quite windy, then you still get your controlled air exchange and air supply.
Yeah, I'm amazed to have an operable skylight.
Yeah, it's nice. Yeah.
Let's go and have a look at that ventilation system. Actually.
So you've got the air supply taking air from the air intake, bringing air in from the outside. On the back you've got the air exhaust, and then from there on in on the other side you've obviously got the outgoing air from all the wet areas going into the unit, and behind that is again the air supply going on all the bedrooms and living areas.
Beautiful. And what does the heating in here?
He's got a fireplace that he's going to set up in the
That's a bit overkill.
It is very much so. Yeah, we've tried to talk him out of this, but he insisted on it. Everyone likes looking at fire. He's got an aircon here if cooling is required, so you can't. It doesn't do any harms. Even if you got a larger unit, you switch this on for half an hour. We've got some sensational data from Tom just after we set up the building shell. So he shifted the controller that he's got, or the thermostat, from his shed into the house the day we were done, and we sealed everything up, and it went immediately, the temperature dropped, and you can see the data from there, the temperature spikes and drops back down. It does get cold down here, and the house was immediately at 20 degrees with no one inside, no ventilation unit running. It was just sensational. It just does what it's supposed to do.
But you've got a split system coming in as well?
Yeah, he's got a split system. That's all personal choice. I never try to talk people out of it. If you want immediate cool air added to the house, that's not a problem.
Split system is very compatible with Passivhaus, isn't it?
Yeah, it works. It's an easy one. It's heating or cooling is not. It's not the devil. A lot of people thinking that's a terrible thing to do.
No, you need it.
It's not. You need it. Needs it. And the statement that in a passive house you do not need heating or cooling is simply incorrect. Yeah, correct. That's not correct. You may need it, but it's very strictly regulated how much heating or cooling you are actually using, and that's perfect. So now it becomes very predictable.
You could potentially even just use a hairdryer.
That's right. Or candles. We built a house in Europe that was entirely heated by 27 tea light candles.
Really?
Works.
That's awesome.
It works.
Wow.
It's quite unusual to see concrete blocks in passive house.
Yeah, it's part of the design. The client's brief in the design stage was simply that there was high winds in the area, and they wanted the house to be sort of tucked into the landscape and sheltered. So what these are, they are actually retaining walls. So the client is going to fill up garden beds around the place, and so that the entire house appears to sort of being set into the landscape later. And this one is sort of like a wind.
And the garden bed is part of the building envelope when you calculate the insulation value?
It doesn't do anything. We deliberately left it out just to be
conservative.
Yeah, conservative.
All right, Burkhard. Well, let's pressure test this place. We're going to need you to seal up the ventilation system. So here's the tape.
All right.
And we'll see where it's at. So Burkhard, not a bad result for the first sort of test.
Not our best, not our worst.
I've got a feeling you've probably already tested it prior to us getting here.
Yeah, we always test them straight after we put them up. We'll just check if everything is all right. There's nothing worse than running around and doing leak detection for days. But it's pretty good. Like, we've had clients that always look at it and they're going 0.58, 0.55, and everyone goes sort of, it's almost disappointed because they're thinking, well, that's close to 0.6, but the average, you would know better than me, the average of a conventional house is what, like 15 to 25 air exchanges an hour. 0.6 is extraordinarily airtight, and I'm wrapped with that. Absolutely happy.
It is quite hard to get a building to 0.6.
You know what? The whole house leaks smaller than people's heating unit.
Yeah, absolutely.
Well done.
Conventional Australian homes.
Yeah, we've got a pretty we're pretty sensational team. So the boys are onto this and delivering every single time. So I'm pretty proud to be part of that team. Yeah.
Well done.
Let's wrap it up. Thanks
stuff.
a lot. Thanks for coming out, guys.
No
Appreciate
worries.
it.
Pleasure.